I did. I don't have gradebook access at home, so
Oh, okay.
I should put them in today.
Okay, I'll just make sure. it's
And
on.
if I overlook them or forget, just remind me.
Okay.
I get marked, it timestamps them, so. Alright, good morning. I need you guys to get out the handouts from last class. There were several of them, and I left them on the front table if you were not here on Friday. So we will be continuing with that. Okay, so last time we finished filling in the rational functions notes, which was all of this stuff. And we had the class before that previously talked about 3 of these. So the first 3 were x-intercepts, vertical asymptotes, and holes. All pretty similar work behind those. So Friday should have been the second day in this class that you've seen them. Then we also went on to talk about how to find y-intercepts, the rules to check for horizontal asymptotes, how to know when there's a slant asymptote and how to find it, and a quick review of domain. And then once we had all of that stuff down, we were able to throw that into a graph. So it looks like, I think you guys made it through question 6, is that correct? Okay. So 6 was homework if you didn't finish that in class. Okay, so let's briefly go over this, and I will verbalize all of the rules, but again, that's usually not enough. That's why we need them written down on that front page there. Okay, so as we practice these today, again, I'm going to go over a few more with you where I will say all of the rules. The more times you hear those rules, the more likely it's going to stick. But realistically, you need to start off with the ones that you find to be the easiest. So I think most people would consider y-intercept one of the easier skills. Y-intercepts always have an x value of 0. Plug in 0 for x and solve, and you should have ended up with 1/4. There's a good point for our table and a good point for our graph in a moment. These 3 are not necessarily quick, but once you get one of them done, the other 2 are usually pretty quick. So for these 2, we have to know what numbers make the numerator 0 and what numbers make the denominator 0. So sometimes you don't need to factor, and sometimes you do need to factor. But any number that makes both the numerator and denominator 0 would be a whole. So there was no number that made that true this time, so you should have said none. Any number that makes just the numerator 0 should be an x-intercept. And there's another point for our table and our graph. And any number that makes just the denominator 0 is going to be a vertical asymptote. So it's vertical spikes in the graph. Now again, sometimes that's more of a pain if these are harder to factor, but that's always going to be the process. Okay, for horizontal asymptotes, this one is also not much work if you know what you need to do. So for horizontal asymptotes, you have to compare the degree of the numerator to the degree of the denominator. And if the degree of the denominator is bigger, it's y equals 0. If the degree of the numerator is bigger, it doesn't have one. And if the degrees are equal, like this one, it is y equals leading coefficient over leading coefficient. So y equals -1/4. Okay, slant asymptote. These only occur when the degree of the numerator is 1 bigger than the degree of the denominator. So all you had to do was check that, see that that didn't match up, and say none. Now, if that had been true, we would have to do long division, and our equation would be y equals the quotient. Ignore the remainder. So if you applied all of that stuff correctly, you have a y-intercept at 1/4, an x-intercept at 4, a vertical asymptote at x equals -4, and a horizontal asymptote at -1/4. So all asymptotes need to be graphed as dashed lines. Of course, all the points you find from the information above, bless you, is helpful. Sometimes you need more points. Sometimes you may want more points. It's never a bad idea to do more points. But in this one, you should have known that this was going to be enough, because you've got these two that are connected. And based on this direction, this guy is going up. So he must go into infinity on this side and negative infinity on this side. It's always going to shoot to positive or negative infinity around every vertical asymptote. So that is predictable. And then horizontal asymptotes and slant asymptotes tell you what your graph approaches on the far right and the far left. So that's why the one you should have done, the end of class on Friday / homework, should look like this. And again, we don't have calculators yet. We won't have our classroom calculators back for a few more classes from AP testing. But if you had your own calculator, or if you're willing to pull up Desmos.com and type it in, you could confirm it as a quick check. Okay, now that I've got the graph in front of me, the domain's going to be quite a bit easier. I can see it hits all of these x values, which would be negative infinity to -4. And it hits all of these x values. -4, and then forever to the right. Okay, so I'm going through that pretty quickly, but again, you should have already tried that one, so we're just trying to fill in the gaps there. Anything that jumps out at you about question 6 before we look at one more together? Okay, then let's do one more together, number 7, and then I'll have you do number 8 as a guided practice question. So again, the rules aren't changing, how to find them is not changing, and that's why with each question it should get easier. So y-intercepts, plug in 0 for x and solve. You end up with -2/3. X-intercepts, vertical asymptotes and holes, all depends on what numbers make the numerator 0 and what number makes the denominator 0. If something is not factored, then you need to factor it to figure out where it equals 0. Numbers that make both the numerator and denominator 0 are holes. Numbers that make just the numerator 0 are x-intercepts. And numbers that make just the denominator 0 are vertical asymptotes. Again, even though this is a lot of information, and I am sympathetic of that, you also have to appreciate, once you know what you're supposed to be doing, I've gotten 4 answers here with about 1 step of work, so that's kind of nice. It's a good trade-off. Okay, horizontal asymptotes, you have to compare the degrees. Since the degrees are equal, it is y equals leading coefficient over leading coefficient. And slant asymptote, I don't have to do that in this question because the degree of the numerator is not 1 bigger than the degree of the denominator. So there's no shortcut for knowing how to find these things. But if we can find them correctly, we've got 2 points and 2 asymptotes. So plot the points, graph the asymptotes, usually a good sign with your graph is everything should kind of come together. If your graph, if you work one of these questions and you're putting this information on the graph and your graph looks really crazy or unusual, that's probably a sign that you missed something. So, all right, well, again, feel free to get more points, especially if you want to increase your confidence in what this is looking like. But we've got plenty here because I've got this point, and I know it has to approach the horizontal asymptote on the right. Based on the direction, I can see this guy's heading down. If it's heading down on the right, it's going to head up on the left, which is good and consistent with needing to hit this point. And not only does it need to approach the horizontal asymptote on the right, but also the left. And then finally, for domain, it looks like it's hitting every x value except -3. So we need these, and we need those. Everything to the left of -3 and everything to the right of -3 would be domain. Okay, so besides the one we went over from Friday, again, I'm going over this quickly, and if it's too quick on something, that's not going to be helpful. So anything you guys want to speak up and ask about before I ask you to try number 8 on your own? Okay, then let me give you several minutes. Go ahead and try 8. Try to do as much of it as you can without flipping back to your notes box on the first page. But when you do get stuck, use your notes. And if that ends up not being enough, then after I go over it, you need to add some to your notes so that it will be able to help you if you forget that thing again.
Mr. Townsend?
Yes.
Since you're gone Friday, can I start working on like the 1 through 5 instead of 8?
Yes, that's fine. Yeah, if you weren't here on Friday and you have not watched that class video yet, I would probably start there. It's pretty hard to just start practicing these without hearing how to find them and practicing them kind of one at a time. So. Now, of course, feel free to just keep on going too. If you get completely stuck and you know you're going to need to pay attention to parts of number 8, but you can't do anything else, go ahead and move on to number 9 and start doing the parts of 9 that you can do. So for question 8, here's what the graph looked like. So if you ended up with a graph that looks the same as this, very, very similar to this, then you're probably fine. The only thing that you could have still maybe missed and not realize it would be the domain. And if you did not get this as a graph, it should give you some hint. Like I see 1 vertical asymptote, so in your work if you had less than that or more than that, then that might be a sign that something about vertical asymptotes is giving you an issue. To me it looks like there's a slant asymptote in this question. So if you didn't think there was a slant asymptote, we need to make sure that we get that cleared up and how to find it. Looks like there was 2 x-intercepts. So if you didn't have 2 x-intercepts, something about that is off. So it gives you a little bit of a hint. But if your graph looks like this and you feel pretty confident, you are welcome to move on and you don't have to follow along with me. But if your graph is not looking the same, then we need to figure out what parts are going differently here. Alright, so if I was to start off with y-intercept and I plug in 0 for all of the x's, I would end up with 0 divided by -9, which is 0. So there's a point for my graph. X-intercepts, vertical asymptotes, and holes all require me to know what numbers make the numerator and denominator 0. So to factor the numerator, you should have taken out a GCF and then factored the difference of 2 squares. Things can factor more than once. The denominator also had a GCF and then factored further. And all of that is for me to quickly see that 0, -3, and +3 make the numerator 0, and -3 and +1 make the denominator 0. I need this information for these 3 parts. 1 makes only the denominator 0. 0 and 3 make only the numerator 0. And -3 makes both the numerator and denominator 0. So the numbers that made just the numerator 0 were the x-intercepts. The numbers that made just the denominator 0 were the vertical asymptotes. And then there's going to be a hole when x equals 3, -3, because -3 makes the numerator and denominator 0. Now for the y value, again, I really think you guys need to put a star by this or highlight this because you don't get to practice this much, and this is just one of those things that doesn't stick as well for students. The y value comes from plugging in the x value into the reduced fraction. Don't plug it into the original fraction, you're going to get 0 over 0. Don't plug it into the factored form. Don't plug it into the factored form. Plug it into the factored form after it's been reduced. So plugging in -3 would give me this on top, so it comes out to be 18. And -12 on bottom. So that reduces to -2/3 or 3/2, -3/2. Now I guess technically you could have missed that as well and your graph still would have looked the same as the calculator. Because remember, our calculator does not do a good job of showing the holes. But we can check that real quick since I have it graphed in here anyway. So if I hit trace -3 enter, it should tell me that y doesn't exist here. Okay, and it does exist there, so that tells me something is off.
When you factor the x squared minus 2x minus 3, it should be x minus 3x plus 1.
You're right. My factoring is off. This should have been a -3 and this should have been a +1. So that would mean this would be a +3 and this would be a -1. So -1 is the vertical asymptote, 0 and positive -3 should be the x-intercepts, and then +3 should be the x value of the hole, because these two cancel. Okay, let's try that again. Divide both by 6. Okay, so maybe there's a hole at 3/3, so that's what I really meant to check. But I've been verbalizing this, but obviously I didn't practice it very well. These factoring pieces, you're getting so much information out of these factored that you do need to slow down and make sure you factor it correctly. Okay, so now if I check 3/3 is supposed to be a hole. So if I hit trace 3 enter, it should say that y doesn't exist. Okay, now that makes sense. There is a hole there. And the closest thing you can do to check your y value is move the cursor a little bit to the left of 3. See that it's around 1.5. Move it a little bit to the right of 3. See that it's around 1.5. And we were saying the y value was 3/2, which is of course 1.5. So 1.5 is this point that is missing. We can tell by comparing the decimals directly to the left and to the right of that. Okay, so now finally that looks good. So horizontal asymptote rules. The degree of the numerator is bigger, so it will not have a horizontal asymptote. But because the degree of the numerator is 1 bigger than the degree of the denominator, it has a slant asymptote. And unfortunately, slant asymptotes are probably the most amount of work that we will have to do in this type. So we have to do long division, and our answer is going to come from y equals whatever the quotient is. We will ignore any remainder. So you should have started off with an x. X times x gives you x cubed, and a 1/3. 1/3 times 3 gives you 1. But also, 1/3 times -6x would be -2x squared. I put it out here. This is optional, but if you line it up with the x's, it looks like it's going to combine with the x's. X's and x squareds are two different things. And then finally, -9 times 1/3. Multiplying by 1/3 is like dividing by 3. So, looks like we would get that. Change all the signs and add. And I'm just going to switch the order of those, so it makes it a little bit easier for me. And then looks like it can go one more time. So I could divide by 3. 1/3 times 3 would give me 1. Make it 2/3. 2/3 times 3 gives me 2. And then 6 divided by 3 would be 2. Times 2 would be 4. And 9 divided by 3 would be 3. Times 2 would be 6. I'm not real interested in this last work because it's going to be a remainder anyway, and the remainder has no impact on the slant asymptote. So long division, ignore the remainder. So some of this information that should be consistent is notice that the origin is a y-intercept, but the origin is also an x-intercept. So if that was not in both lists, that would be off. And I think I've got a point at -3, 0. I've got the hole, even though that's not a point on my graph, it should still help me. I've got a couple asymptotes, so I think it's time to start the graph. We plot the points, graph the asymptotes, even the slant asymptote. free to throw in more points if you think you need to, or if you're not sure, just always do more points. Again, don't pick x equals 10. That's going to be really hard to figure out without a calculator. Plug in like x equals 1, x equals 2, x equals -2. Easy stuff. And I think we've got enough for our graph now. I think it's ready to come together. If I know it goes through this point, and I know it has to approach the slant asymptote the same way it has to approach horizontal asymptotes, and this point needs to approach the slant asymptote on the other side, based on the direction of both of those, it must be going to infinity on this side and negative infinity on that side. Now, if we asked you to graph this on a test, there's still one important thing that I'm missing. What did I not put on my graph?
The whole.
Right, and that is important. When x is 3, y was 1.5. You need to show that as a big open circle. That's an important characteristic of the graph. In fact, it would have helped me graph too, because even though it doesn't hit this point, it has to hit the points right before it and right after it. So I guess I didn't need it to know what the general shape of my graph was, but it certainly is nice to see that it's consistent with everything else. Okay, and then the domain, I'll copy it up above, but now we can see the x values that it hits, and you need to be careful. Your domain should be in 3 intervals, not 2. So even those of you that felt like your graph looked good and you've been ignoring this because you've been on the right track, your domain can still be wrong. So you should have negative infinity to negative 1 for these x values. You should have negative 1 to 3 for these x values. But you can't include 3 because x equals 3 doesn't exist. It skips that spot because of the hole. But then it hits 3 to infinity. So I'm just concerned that you may not have done that part of the domain. So double check that. Okay, and then 2 big things before we move on. One is, if there's something I'm going over too quickly here, I need you to tell me anything that you want me to repeat again or have a specific question again, and potentially updating your notes on the front box on page 1. So anything about question 8 I can go over again, or you guys need to ask about? Okay, then go ahead and try number 9, and I'll give you 6 or 7 minutes. Again, it should be getting easier. If you're really putting in your best effort, it should be getting easier. so that was 7 minutes already. So if you're still working on that one, then something is not clicking quite yet. Okay, so this is what the graph in number 9 should look like in the end, and I suspect even if you were feeling pretty good about this, you might have gotten something incorrect about the middle of this graph. But if your graph looks the same as this, then you can probably keep on going. You're probably in good shape and don't need to hang back with the rest of us. Okay, so let's see, y-intercept, you should have gotten 0, 0. Plug in 0 for x and solve for y. You ended up with 0 divided by -3. For x-intercepts, holes and vertical asymptotes, I'm not going to make the same mistake I made a minute ago. I'm going to factor a little bit more carefully. Actually saves me time in the long run anyway. So it looks like the numerator equals 0 at 0 and 4, and the denominator equals 0 at 3 and -4. Wait, that's not a 4. That would be a 1. There we go. 3 and -1. So no number makes both the numerator and denominator 0, which is how you get holes. Two numbers make the numerator only equal 0, so those show up as x-intercepts. 0 makes sense because the origin is not just an x-intercept, it's also a y-intercept, so this should be consistent. And then vertical asymptotes should be numbers that make just the denominator 0. So two of those. Okay, you check the horizontal asymptote rules. This is where you compare the degree of the numerator to the degree of the denominator, and since they are equal, it would be leading coefficient over leading coefficient, y equals 3. Slant asymptote is only if the degree of the numerator is 1 bigger than the degree of the denominator, which is not true here. So we've got 2 points and 3 asymptotes for our graph. Crosses the x-axis 2 places, and there are 2 spikes in the graph, x equals 3 and x equals -1, and a horizontal asymptote at y equals 3. So this is what I have to go on thus far. Now, here's the parts that is safe to assume and what's not safe to assume. I kind of suspect that in the middle of this graph, either your graph got really confusing and it didn't seem like something was right, or there's a good chance you made an assumption here about the middle of the graph. But what is okay to assume is we've got this point, and he has to approach the horizontal asymptote on the far right. And then based on this guy's direction, he's going down to -infinity, which means this one goes up to +infinity. And then probably where you may have been confused is how's it supposed to hit this point if it's way up here? And the thing is, with horizontal and slant asymptotes, again, all they tell you is what's happening at the ends of the graph. If your graph has 3 or more sections in it, it can actually cross through that. There's nothing wrong with that. It can't cross it on the far right or the far left, but if there's a middle section, it can actually cut through there. And if it makes you feel better, you could plug in x equals 1, see that it's somewhere around 2, plug in x equals 2, see that it's somewhere around 3 or 4. Like, you can find these actual points if you're skeptical. But then based on this guy's direction, this goes down to -infinity, so this guy goes to +infinity, and then he's got to approach the horizontal asymptote, so something like that. And if I try to compare my graph to the calculator's graph, again, it's never going to be exactly perfect, because the calculator is graphing 1,000,000 points. But that looks pretty good. Nothing obviously wrong with that. So, last thing to finish up this one is domain. Looks like we can hit all of these from negative infinity to -1. Then we can hit all of these, which would be -1 to 3. And then finally all of these, which is 3 to infinity. Okay, any questions about how I found any of that or how I got any of that applied to the graph? Okay, and again, I know I've been verbalizing this, but this is important. If there's one or two of these things that you are struggling with, consider rewording your definition on that front page or adding a quick example or two, or just being more detailed. Make it to where if you know this box up front, you can do all of them. So take a moment to do that if you need to, and then move on to the next question. And we'll do one more guided practice question up on the board, number 10. And then with the rest, after I give you enough time, I'll share the graphs and then I'll let you ask specific questions instead of going over the whole thing. So. But move on to number 10, please. It's been 7 minutes. So for question 10, your graph should have looked like this in the end. So that should give you a quick idea if you need to follow along with me or not. Again, this does not guarantee that you got the whole part of the question correct, and it does not guarantee that you got the domain part of the question correct. But if your graph looks the same, then you must have gotten the same x-intercepts and same vertical asymptotes and same slant asymptote and all that kind of stuff. Okay, so if you did not get that, let's see. Start off with y-intercept, plugging in 0 for x and solving for y. You get 0 divided by 24, which would be 0, 0. Which is the origin, so this should be an x-intercept too, but I don't need to just copy that over, I need to work that out the long way. The numerator factors as a GCF, and as a difference of two squares. Okay, the denominator was a GCF and a trinomial. 3 numbers that makes the numerator 0, and 2 numbers that make the denominator 0. Looks like no number was in both lists, so no holes. 3 numbers that made just the numerator 0, so that's why we end up with 3 x-intercepts. And 2 numbers that make only the denominator 0, which is why we end up with 2 vertical asymptotes. And of course that right there is already the bulk of the graph. Unfortunately, this one does not have a horizontal asymptote because the degree of the numerator is bigger. I say unfortunately because a horizontal asymptote helps us with our graph, and if we don't have a horizontal asymptote, the odds of us having a slant asymptote is much higher. This one unfortunately does have a slant asymptote because the degree of the numerator is 1 bigger than the degree of the denominator. And the only way for you to find that is long division, ignore the remainder. So looks like we should have gotten a negative 1/4 x. Thank you. Oh, I got that backwards. Sorry. Got to set it up correctly. Should be dividing this one into that one. Okay, and then this would be negative 1x squared and minus 6x. Change all the signs and add. And then once more, negative times a negative gives a positive. 1/4 times 4 gives me 1. And x squared, so I already got the x equals. I should have just combined these. Okay, so as usual, I get a little bit careless at the very end of this because I know it just doesn't matter. The slant asymptote comes from just the quotient part. So it's an equation. We need y equals, but very subtle. Okay, if I start to graph that slant asymptote, it's an mx plus b format, so it's got a y-intercept of -1/4 and a slope of -1/4. So down 1, right 4. Something like that. Include the verticals. And include the x-intercepts. And then your graph should be just about finished. So your function's going to behave the same way at the ends of the graph for slant asymptotes that it does with horizontal asymptotes. So this is going to have to approach this. This is going to have to approach this. Based on this guy's direction, he's going down, so then up on the other side, which is good because then it lets me see how it hits this point. And over here, again, if you're unsure, you're welcome to plug in a couple more points. That's never a bad idea. But this direction means this one's going up, so down, and then it must be connecting there. So, and then just a quick 5-second snapshot, this compared to this. That looks pretty good to me. So, no obvious errors. Okay, and then domain, since the graph is all completed now, be -infinity to -2, and -2 to 3, and 3 to infinity. Okay, any specific questions you guys like to ask about 10? Okay, then let me give you some time to try 11, and while you do that, I'm actually going to put the graph of 11 up on the board. So as you finish that one, you have an idea if you need to stick with it a little bit more or ask some questions in a minute. So again, this next one I'm not going to work beginning to end, but I would be happy to work whatever parts of it you want me to work out. So number 11, if you don't end up with that as a graph, try to find your mistake and try to be ready to ask some specific questions in the next 6 minutes.
I want to ask about the quiz we took last week. I know Andrew said that you X'd it out. Could you do the same?
Yes, I will. Did I not already?
No. I don't believe so. And then the assignments from last week for it, are those, do you want me to complete those as well?
If you want the points for them, the ones you needed to do were 111 and 112, so I can still take those.
Okay. I don't have them, but
Okay, well I can still take them by Wednesday or something,
okay.
if you think you need the points, but
Okay. What did that, when you X'd it out, what did it bring my grade to?
I don't know what it was before, but that's what it's showing right now.
Okay. And then how many points is the review packet?
And actually, you don't have to do that part either. That part wasn't part of your file. That I don't know. I need to check with Miss Thomas on that.
Oh.
So that pulls you to. That gets you to that now. Because there's one assignment in there I had to zero that you weren't responsible for.
So I'll try to get these graded today, but it may not be till Wednesday.
Okay.
That's when my
And
other
then the
things.
final is just it covers the lowest test score of the.
And it counts as a 50-point test.
Okay. Sounds good.
Do you have any other classes? Something to do here for today? Okay, you're welcome to. You don't need to stay for me.
You said the grades will be in by Wednesday?
For sure by Wednesday. I will try before then, but
They won't give me my folder until I have my grade.
well, I don't think senior grades are due till Friday, so I don't know what their plan is with that. So,
How can we be sure that there's nothing here?
well, because it's a function, and if there was stuff here, it wouldn't pass the vertical line test.
Oh, okay.
Okay, I think this was number 11. Any parts of 11 you'd like me to go over to help you see where this graph came from? Okay, then I'll do the same thing with 12. Since I don't have classroom calculators, I will put the graph up here. Okay, that's what you should be aiming for on number 12. So if you're far off from that, please be ready to ask me to work some parts of 12 with you in the next 5 or 6 minutes. it's not really part of the graph. This stuff is the graph, but we use the graph as a dash line because it helps guide us when it's supposed to look like. So no, it's not really part of the graph, so it doesn't matter what it's doing. Okay, so for this one in this graph, I think this was question 12. Any parts of question 12 you'd like me to go over to help you get closer to that graph? Okay, I will graph one more for you. How many is there total here? 15 questions? 14?
14.
14. Okay. So you do need to, whatever you don't get to in class, you guys still have about 8 minutes here. But what you don't get to in class, I do need you to do for homework. First thing we will do on Wednesday is I will share the graph of number 13 and 14 and give you a chance to speak up and ask those questions. And then you'll get a little bit more practice on this stuff again by going back to the test review that you've already done the back page for. But this is what 13 should look like. So if you're already finished with 13, give it a quick glance. And if you're not, you might do a quick little, or just very faintly sketch it in your graph so you know what you're aiming for when you go to finish it up. But please finish the rest of these before Wednesday.
Is our test on Friday or next week?
I've got to check.
Well, it can't be Friday, because then this would be week.
Maybe.
Last week was an A week, so I'm just assuming this is a B week. This would be. Start that here. You see, so yeah, we will work on the review Wednesday, which puts our next test on Monday.
Okay.
Monday of next week.
But you guys have seen all of it. It's just a matter of practicing this until you feel comfortable.